Hi everyone, welcome back to Prieto TV and welcome to the new episode of Prietology. So as we learned last class, we learned about what acids and bases are and we learned how they're related and how they are measured. This lesson is basically going to bring all the episodes that we've done together. So in the first episode we learned about the basics like states of matter and compounds and mixtures. The second episode we learned about the parts of atoms like protons, neutrons, electrons, molecules, ions. And last episode we learned about how acids and bases are related and what they are. This episode is going to bring together all of them and how they react with each other. So this episode, like I said last time, is about chemical reaction and my things go boom. Hi boss, does that mean we get to blow things up today? Absolutely not, not in here. What about like dissolving or setting things on fire or exploding or lasering or whatever there is in chemicals? No, just no. Okay, how did you even get inside my home? You're supposed to be at the lab. Well, yeah, how did I get inside? Man, I'll just leave you. But sorry, boss. Okay, so as you see, our lesson is called Why Things Go Boom. So today's key terms, we only have 5 key terms today. We have chemical reaction, reactivity series, combustion, activation energy, and catalyst. So let's start with chemical reaction. Okay, so our first key term is chemical reaction. Chemical reactions are electron interchanges between molecules. So when you put two chemicals together, basically when they react, they're switching electrons between each other, filling up their shells. And there's 2 key types of reactions. There's oxidations, which are losses of electrons. So if a molecule loses an electron, and reduction, which is when a molecule gains an electron. And there's also 2 types of chemical reactions. There's endothermic and there's exothermic. Endothermic likes to suck up all the energy as like heat or light, and then exothermic likes to puke out energy as in like heat or light. So usually in chemical reactions, they have like special equations. Like up here, this is an example of a chemical equation. It has 2 hydrochloric acid molecules, 2 sodium molecules, and the arrow means that when you add those 2 together, they turn into 2 sodium chloride molecules and 2 hydrogen molecules. Okay, so the product, the ingredients required to make a chemical reaction are called reactants. And then once that finishes, the results of the chemical reaction are called products. And then the speed at which it happens, like some reactions can happen very slowly, like when iron rusts, it happens very slowly, not like in an instant. Or sometimes they can go really fast, like when you put baking soda with vinegar, it goes super fast. That's called the rate of reaction. And the rate of reaction depends on concentration, pressure, temperature, and a bunch of other different factors. Okay, so our next term is reactivity series. Reactivity series is basically, it's a chart. Here's a picture of the reactivity series. The reactivity series is basically a chart that tells you how violently a metal, any metal, will react with others. Not just any metals, the metals from the periodic table. So the more reactive the metal, the more readily it will lose its electrons. So, like I said, chemical reactions are just interchanges with electrons. So if it's more reactive, it's more likely to lose its electrons faster. And basically it lists them from top to bottom reactivity. So if you saw the picture, the most reactive is potassium and the least reactive is platinum. I think the order is, it's potassium, then sodium, then lithium, calcium, magnesium, aluminum, zinc, iron, tin, lead, copper, silver, gold, and then platinum at the bottom. So yeah, that's basically what the reactivity series is. Okay, so our next term is combustion. Combustion is the combination of the 2 types of chemical reactions we saw, the reduction and the oxidation. It's called redox. It's basically a fancy chemical name for burning. Combustion is basically a fancy chemical name for burning. And it's a type of chemical reaction when the fuel, which could be, it's not just fuel like lighter fuel, it could be wood or paper, anything that helps it keep going. It's when the fuel combines with the oxygen part of air. So like the oxygen molecules is basically when it does. So the fuel and the oxidant can react to make heat and light. So basically the results of redox, aka combustion, is heat and light. So always The products of this type of reaction it will always be oxidized, which means they will have oxygen. So yeah, let's move on to the next term. Okay, so our next term is activation energy. Activation energy is the energy needed to start a chemical reaction. So an example of this is like if you're trying to start a fire and the wood is wet, it's harder to start the reaction because it's not dry and coarse. So the higher the activation energy needed to start a chemical reaction, the more energy is needed to start it. So before the compound's reactant reacts, the stable chemical bonds have to be broken with the activation energy. So if they're tighter bonds, you'll need more energy. If they're weaker bonds, you'll need less energy. So some sources of activation energy that probably occur in real life are heat. Like to start a fire, some people just rub wood together to start a fire. Light, you could use light from the sun and a magnifying glass to like set a piece of paper on fire, or a spark like in lighters. There's a little thing in here called piezoelectric. It's a little crystal, I think, of quartz. So when you like when you click the button here, this button, it hammers right on top of the piezoelectric, and that creates some electric current. And the electric current goes to the gas tank, which makes the fire. So basically, the piezoelectric is the activation energy in a lighter. Okay, so this is our last term. Our last term is catalyst. A catalyst is a substance that makes a chemical reaction to go faster. So when you put a catalyst in a chemical reaction, it makes it go faster. And it also lowers the reaction's activation energy. So if you put it before, you'll need less energy to start the reaction. So like if you have some like damp wood, and then you need a lot of energy to get it starting. But if you put some dry wood on top of it, it'll help it go faster, and you'll need less energy. So since less energy is used to start the reaction with the catalyst, it can happen at lower temperatures. And some top catalysts I think you have in one of the top catalysts that chemists use, I think you have in your house, is graphite. This is a pencil. This contains graphite. Lead is not in pencils. Lead is very poisonous. This contains graphite. All pencils contain graphite, and also another common one is platinum. And enzymes are a catalyst in your body. Enzymes are in your saliva. They help break down food with chemical reactions, and basically enzymes are catalysts in your body. Well, I think we covered all the key terms today, so let's get on to experiment of the day. Okay everyone, this is experiment of the day. The experiment is called the release of gas. So what you need is some sodium bicarbonate, aka baking soda, some vinegar, some water, a clear glass, and a match. We don't have matches, but we have this toothpick, and hopefully it will work. Okay, so what you do, you have to fill the glass 1/3 full of water. That's about 1/3. Add a teaspoon of baking soda and a tiny little bit of vinegar, because you don't want to start a vinegar and baking soda reaction. So we add that to the water. Nothing has happened, and now open the vinegar and just add a little bit of vinegar. Here we have our match. Okay, so we're gonna add it, and we should see a reaction. There we go. Now we light this match.
Use an actual match, people.
And it should go out. Boom. The match goes out. Let's try that one more time. It goes out. Okay, so some of you might be asking, what is happening? So the sodium bicarbonate, aka baking soda, is a compound of sodium, hydrogen, carbon, and oxygen. So the reaction between the sodium bicarbonate, aka the baking soda, and vinegar, as we all know, is bubbles and foam and fizzing. So when they react, the reactants are the vinegar and baking soda, and the products is carbonic acid and carbon dioxide. And the carbon dioxide gas, as we all know, extinguishes flames. Here, the chemical formula is up here if you want it. Okay, so this is how our classes are gonna work. Next class is our last episode of season 1. It's our last chemistry episode, episode 5. I'm gonna leave it a surprise, so I don't know. I don't want to tell you guys about it. So thank you for watching. Like, share, and subscribe. Get this video to the front page, and I'll see you later.